Hello friends, now let us continue about our discussion based upon HDFS design. So inside that we have already talked about the blocks in brief. Now let us see what is there inside this blocks in detail. So inside this we are making use of the file system where a disk has a block size which is minimum amount of data. This is with respect to the normal file system, not the HDFS, not the HDFS. So a disk has a block size which is the minimum amount of data that it can read or write. File systems for a single disk built on this by dealing with data in blocks. So we see that let it be in any of the disk systems, we see that file systems are written in terms of blocks. So the file system blocks are typically a few kilobytes in size, whereas disk blocks are normally 512 bytes. So when we are coming into HDFS design blocks, then the HDFS is also making use of the block concept, but the size is 128 MB. So in the previous section we have seen that the file size is only about 512 bytes, the block size, but here the block size is about 128 MB, and that is by default for almost all the HDFS. So like in a file system, for a single disk, files in HDFS are broken into blocked size chunks which are stored as independent units. So let us understand this by making use of a small example where we are having a file with the size of 612 MB. Then it is broken into 128 plus 128 plus 128 plus 128. So we are left out with only 100 MB, which is written in the last node called as E. So this is block A, B, C, D and E. All of them together are nothing but our file. So a file is being broken into certain blocks in HDFS in the form of 128 MB per block. So what are the advantages? A file can be larger than any single disk in the network. So there is nothing that requires the blocks from a file to be stored on the same disk, so they can take the advantage of any of the disk inside the cluster. So when we are having a very large files in terms of gigabytes or in terms of any terabytes or anything in terms of petabytes, then instead of going for a single system, we can make use of multiple disks which are stored inside the cluster. So here the cluster is nothing but a many number of systems present inside any geographical area. So whenever we are trying to work with this, the storage subsystems has to deal with the blocks, simplifying the storage management and metadata concerns. So whenever we are making use of blocks, then the storage management becomes very simple. Now let us assume that whenever we are trying to distribute display any files, then we are having the metadata. When we are trying to display the details of files, we see that the metadata is also been written there by using the file size and so on. So whenever we need to have the information about that file, the metadata will be different for different files. But when we are having a same type of block size, then the metadata is not a big concern because it is having the same size. So blocks fit well with the replication for providing fault tolerance and availability. So whenever a certain block is not working well, then automatically we can just go for the alternative block which is present in the form of another memory or another disk which is present in any other machine inside the cluster. So why is blocks in HDFS so large? So when we say it is 128 MB, then it is very large compared to the normal file system. But let us see a small thing where now exactly what happens is when we are making use of the computer systems, normally our networks is having 100 Mbps or 100 megabytes per second, which takes around 10 milliseconds for transfer. This one seek time is nothing but the movement from one particular block to another block. So when we are having a speed of 100 megabytes, then the seek time will be 1% of the transfer time. So we need to make the block size around 100 MB. That is, for 1 millisecond or for 1 second we need 100 MB. But we see that the block size cannot be 100 MB. So for that we need to make use of 128 MB. So if the transfer rate is around 200 MB, then we may go for 256 MB size, and so on and so forth. So in this we are coming across the name nodes and the data nodes as well. So an HDFS cluster has two types of nodes operating in the master worker pattern. So the name node is the master and the data node is a worker. So the name node maintains the file system tree and the metadata for all the files and the directories inside that particular tree. So this information is stored persistently on the local disk in the form of two files. So the image, namespace image, and the edit log. So the name node also knows the data nodes on which all the blocks for a given file are located. However, it does not store block locations persistently, because this information is reconstructed from the data nodes when the system starts. As I have told already, name node is the one which contains the information about the node, about the data, but not the exact data. So for that reason we say that it does not store any block locations persistently. So this information is reconstructed from data nodes when the system starts. So name node. So the name node stores information about blocks, locations, permissions for the particular blocks, etc. on the local disk in the form of two files. One is FSI image, stands for file system image. It contains the complete namespace of the Hadoop file system since the name node creation. So it contains the information about the complete blocks of the data when it was created. Edit log, it contains all the recent changes performed to the file system namespace to the most recent FSI image. So what are the functions of the HDFS name node? So it executes the file system namespace operations like opening, renaming, and closing of the files and directories and so on. The name nodes also manages and maintains the data nodes. It determines the mapping of blocks of a file to data nodes. Name node records change made to the file system namespace. It keeps the location of each block of a file. Then it keeps the location of each block of a file. Name node takes care of the replication factor of all the blocks, like I have already said, whenever we are making use of the HDFS, there are many copies being maintained inside the cluster. So it takes care of how many replications must be done inside the cluster for a particular block. Name node receives heartbeat and block reports from all data nodes that ensure data node is alive. So it just sends in message so that acknowledgement is being sent back to the name node, saying that the data node is still alive, it is not corrupted, and so on. So it will be on getting the information about the name data node every time. So if the data node fails, the name node chooses new data nodes for new replicas. So these are the functions of HDFS name node. Similarly, we have a HDFS data node, where data nodes are called as the slave nodes in the Hadoop file system. Then data nodes are inexpensive commodity hardware, as I have already told you. So they store blocks of file. So the functions of a data node are data node is responsible for serving the client a read or write request. Based on the instruction of the name node, data nodes performs block creation, replication, and the deletion of the particular blocks. Data nodes send a heartbeat to the name node to report the health of the HDFS, and data nodes also sends block reports to name node to report the list of blocks it contains. So how exactly these are going to function inside our HDFS? So here we have something called as name node, and here we have one client. So let us assume that the client is requesting some information from the data, then the name node is going here, then by making use of the metadata and so on, the name node is being transferred to the data nodes where he gets all the information about the data nodes and so on. Then if there is any replication to be done, then the data node is going to make use of the replications everywhere in the, this is rack 2 and this is rack 1. So he goes here, then let us assume that this data is not present properly. Then what exactly happens is it goes to the replication data, and through the rack 1 the data is read and it is fed to the client. So similarly we can see another this is the reading operation, and when a client is trying to write that, then he is directly trying to write into the data nodes, and whenever he is trying to write the data nodes, then even the metadata is also being created by the name node. So this is how the name node and data node work together. So while writing the block, the client, or there is a single writer, as we have seen before, the single writer is going to write the nodes, and the name node which is created for that particular block is going to write the metadata for that particular block. Okay. So let us conclude this session now. Let us continue in the next session.